Hi, and welcome to another Dante tutorial. This time I'll walk you through creating a linear immersion quench simulation using Abaqus. I'll start by opening up Abaqus CAE and selecting Standard/Explicit Model. Click File and Save, renaming it whatever you like. I'll name this Abaqus Linear Immersion Tutorial. For this tutorial, the Cylinder 500 axisymmetric file should be available under the tutorial files within the Dante files, but if it's unavailable, I've included it in the description. It will be used as a geometry. Go to File, Import, then Part and set the filter to find STP files and select the provided file. Switch to the Part Attribute tab and select Axisymmetric and then click OK. Switch the module to Assembly, then click Create Instance and then OK. Change the module to Mesh and for the object, select Part, making sure the cylinder is selected. Under Mesh, select Controls. Under Element Shape, choose Quad and change the technique to Structured before clicking Done. Now I'm going to seed the edges. Select Seed on the hotbar and click Edges. While holding Shift, select the top and bottom lines of the geometry and click Done. Now change the following attributes: method by size, single bias, minimum size to 0.2, and maximum size to 3. Click Select under Flip Bias, and while holding the Shift key, select the top and bottom of the geometry before clicking Done. I'm going to do the same thing for the side edges by going to Seed and Edges and selecting the side edges. Method will be by size, bias is none, and sizing controls is set to approximate element size to 5. Click OK and Done. Next, mesh the part by selecting Mesh in the hotbar and clicking Part, then Yes. Under Mesh again, select Element Type, and under Family, choose Heat Transfer before hitting OK. Switch to the Parts module, and under Tools in the hotbar, select Set, then Create. I'll name it All Elements and click Continue. Box select the entire geometry and hit Done. Switch to the Assembly module, and from here, go to Tools, Set, and Create. Enter all nodes for the name, and check Node under Type and click Continue. Box select the entire geometry and click Done. Again, go to Tools, Set, and Create, but this time, I'm creating a monitor node so that I can see how the material moves during the simulation. I'll name it A Monitor Node, and click Node under Type and Continue, selecting the upper right vertex before clicking Done. I'm also going to create a fixed node. Go to Tools, Set, and then Create, naming it Fixed Y Node. Click Node under Type and click Continue, selecting the bottom left node and clicking Done. To apply a surface, go to Tools, Surface, then Create. I'll name this Exposed Surfaces and then click Continue. Box select the upper, lower, and right edges and click Done. Now that we're done with the geometry setup, I'll now set up the thermal model and boundary conditions. First, I'll rename the model to Linear Immersion Tutorial Thermal. Go to Plugins and select the Dante Model Builder. Set the model type to Thermal, create Dante Model, and click Yes. Thermal should be displayed in the active model header. I'm going to save here as well. From here, I'll assign the material. Go to the Materials tab, and under Part Element Set, select the cylinder part. For the material name, set it to S10XX and click Add Material Selection, then Dismiss. Switch to the Steps tab to create the heating step. Change the step name to Heating, set the time period to 3,600 seconds, or 1 hour, and set the previous step to Initial, and click Create Step. You can also add a description to each of these steps, which is what I'm going to do, but it won't affect your simulation. For the transfer step, set the previous step as heating and the time period to 15 seconds, then create step. Next, for the immersion step, set the previous step as transfer and the time period to 51 seconds, then create step. Next, the quench step has a period of 900 seconds, with the previous step being the immersion step, and then create step. Lastly, for the cooling step, set the previous step as quench and the time period to 7,200 seconds, and create step. Now that the heating process steps have been created, I'll set the monitor node by clicking the checkbox next to the monitor node and select the monitor node we created earlier. Make sure to also save your progress. Moving on to the initial conditions, go to the Initial/Boundary Conditions tab and click Add Initial Condition. Check the constant value and enter 20 degrees Celsius, then click Apply and Dismiss. Select Field Type and set it to Total Carbon Weight Fraction and set the constant value to 0.002 for AISI 1020 steel. And click Apply and Dismiss. Next, under Field Type, this time select Phase Transformation Kinetics. Set the constant value to default, which is -4, before clicking OK. Click Add Film Property and enter Furnace as the name. Check Temperature Dependence and right-click the table and select Read from File. Click the folder icon and navigate to the generic HTC data folder inside the Dante files. For this tutorial, I'll choose the generic furnace heating file. Click OK and OK to read HTC data and dismiss the CAE message. Left-click and highlight all the non-numerical data and delete, then apply and dismiss. Now I'm going to do the same process for the oil film property. Enter oil as the name and right-click the table and select Read from File. Clicking the folder icon, but this time using the generic oil quench file, and clicking OK and OK to read HTC data. Highlight the non-numerical data and delete those and click OK. Now click Add Interaction, and for the heating step, set the constant ambient temperature to 875 degrees Celsius and hit Apply and Dismiss. Set the interaction step to transfer and set the constant ambient temperature to 400 degrees Celsius and click Apply. Set the step to immersion and check quenching method and click Quench Parameters. Select the quench surfaces and set it to exposed surfaces. Enter 10 for the constant quench speed and enter 65 degrees Celsius for the ambient quench temperature. And lastly, set the ambient quench HTC to oil before clicking OK and Apply. Next, for quench step interactions, check HTC versus temperature and set it to oil. Check constant ambient temperature and enter 65 degrees Celsius before clicking Apply. For the last interaction step, set it to cool and check constant HTC, setting it to 0.0001, entering 20 degrees Celsius for the constant ambient temperature, and click OK. Finally, we're going to run our thermal model. Before we do that, make sure to save your progress. Go to the Models tab and hit Submit Job, clicking Yes to writing the input file. Once you get the notification that the file was written, dismiss the notification and cancel out of the Dante Model Builder. To view your results, go to the File and Open, filter for Output Database or ODB files, and it should be in the working directory. Select it and click OK before switching to the Visualization module. Finally, click Plot Contours on Deform Shape to check results. From the output variables, you can choose any of these to visualize several things such as microstructure or hardness. The simulation should be set to NT11, which shows temperature, and you can use the frame selector to navigate the results. Under output variable, you can search for several things, including SDV VF perlite, which shows as perlitic microstructures. From here, we can make a few adjustments so that we can make a stress model as well. First, we must close out of the existing output by expanding the output databases in the model tree. Right-clicking the Open ODB file and clicking Close. Open the Dante model builder back up and enter a new name under the model name. Switch the model type to stress and click Yes. Make sure to save your progress here. Select Mesh and Element Type, box selecting the entire geometry and clicking Done. Select axisymmetric stress under Family and uncheck Reduce Integration in the Quad tab. Click OK and Done. Going back to the Dante Model Builder, switch to the Initial Conditions tab and click Add Displacement Boundary Condition. Under Set, select the fixed Y node and then check U2 before clicking OK. The stress model is now ready to run, so similar to the thermal model, I'm going to save my progress before switching to the Models tab and clicking Submit Job and Yes. Abaqus will tell you it's done in the description. To view your results, I'm going to do the same thing as the thermal model and going to File, Open, and Filter by ODB files, this time choosing the stress model we just created and switching the module to Visualization. Click Plot Contours onto Form Shape to check results. S should be set as the default, and you can use the frame selector to navigate the results. Under Output Variable, you can set it to U, which is the magnitude of the displacement. Select Output Variable U1 or U2 for displacement along the X and Y axis. And this concludes our Dante tutorial. If you have any questions, feel free to comment down below or send us a message at support@dantesolutions.com. Thank you for watching and happy simulating.